Hello dear students. In the previous video we learned about matter and the different states of matter, that is solid state, liquid state and gaseous state. In this video we see that can matter change its state. That means if there is a particular matter, can it change its state? So we start this one with the help of one example. Water can exist in three states of matter. Okay. Water can be either in solid state, that is ice. Ice is the solid state of water. It can be in liquid state, that is the water itself, and it can be in gaseous state, that is water vapor. So water can be present either in solid state or liquid state or gaseous state. So from this example we know that yes, matter can change its state. But the point is, how matter is able to change state, under what condition, under what are the circumstances under which a matter can change state. So here the question arises is what happens inside the matter during the change of state. Whenever a change of state is taking place, what happens to the matter? What happens inside it? What happens to the particles of matter during change of state? Whenever there is a change of state, suppose ice will convert itself into water, water will convert itself into steam or water vapor. So what will happen to its particle? How does this change of state take place? So even if the matter, or for example water, is able to change itself into from one state to another state, how this change is taking place? So we are going to discuss all these questions in this video. Okay, so let us start. The effect of change of temperature. Whenever the state of a matter changes, there are two factors on which it depends on. First one is temperature, second one is pressure. So first of all we discuss about effect of change of temperature. You know that when you increase the temperature of ice, suppose ice is inside the freeze, when you bring the ice from the freeze and keep it in outside, after some time you might have observed that it started melting. So the temperature inside the refrigerator is less than the temperature outside the refrigerator. So when the temperature increases, ice will convert itself into water. So temperature plays a vital role while changing the state of any matter. So first point, on increasing the temperature of solids, the kinetic energy of the particle increases. As you know that suppose this is a matter which is in solid state. Now all these are tiny small particles. Okay, they are very close to each other. So when the temperature increases, the kinetic energy of the particle increases. What is kinetic energy? Kinetic energy is associated with the motion. Whenever something is moving from one place to another place, it is said that it is having kinetic energy. So previous class we saw that the particles are not stable. They are vibrating about their mean position. So when the temperature increases, the vibration or the motion of the particle increases, that is their kinetic energy increases. Earlier, when the state of matter, when the ice was at certain state, its molecule were vibrating little bit. Now when the temperature of the ice is increased, the molecules are have started vibrating with some different speed, with certain more speed. So due to the increase in kinetic energy, as the kinetic energy of the particles increases, the particles start vibrating with great speed. Okay, so the energy supplied by heat overcomes the force of attraction between the particles. So you know that between these particles there is a particular force of attraction. Now this force of attraction, which is also known as intermolecular force of attraction, decides whether the particle will be in liquid state, solid state or gaseous state. Due to the application of the heat, as the kinetic energy increases, the particle will start vibrating with more speed. So as the speed of the particle or the kinetic energy particle overcomes the force which for which the particles are sharing a bond among them. So that force of attraction is now broken due to the motion of the particle. Now the particles leave their fixed position and start moving more freely. A state is reached when the solid melts and is converted into liquid. So here what happens, initially the particles are binding with each other with certain force. When you increase the temperature, the particle will start moving here and there. But due to the intermolecular force of attraction, the particles are binding at a certain place. But when the kinetic energy of the particle increases, the kinetic energy is high enough to break the bond between the particles. So as the bond of the particles broken, the entire material or the entire matter is converted itself into liquid state. Okay. The particles leave their fixed position and start moving more freely. A state is reached when the solid melts and it's converted into liquid. The minimum temperature at which a solid melts to become a liquid at the atmospheric pressure is called melting point. This is very, very important. So melting point is the temperature in which at atmospheric pressure, that means at normal atmospheric condition, the solid will convert itself into liquid. For example, ice converts itself into water at 0 degree centigrade. So 0 degree centigrade is the melting point of the ice. Okay. The melting point of a solid is an indication of the strength of the force of attraction between its particle. More is the melting point of the solid, more will be the intermolecular forces of attraction among the particles of the solid. The process of melting, that is change of solid state into liquid state, is known as fusion. So fusion, this is also important. Fusion is the process in which the solid particles will melt itself into liquid. Melting point is that particular temperature on which the solid will melt into liquid. Okay. Now next point, when a solid melts, its temperature remains the same. So where does the heat energy go? So before we just discussed that whenever a solid is melting, it is transferring itself into solid state to liquid state. Okay, but during the phase where the solid start melting, the temperature does not increases. So as you know that suppose this is a piece of ice, suppose its temperature is minus 5 degree centigrade. Okay, when you supply heat, its temperature will increase. You are supplying heat continuously, its temperature will increase and become 0 degree centigrade. Okay. Now from 0 degree centigrade ice, it start melting. Okay. This ice cube needs certain time to melt. Okay. So with respect to time, the temperature of the ice cube should also increase. But here what happens? From 0 degree centigrade ice till each and every single ounce of ice is completely melt into water, the temperature is not going to change. Okay, that means suppose this ice piece needs 15 minutes to melt itself into water. So for these 15 minutes, even if the ice cube is acquiring temperature from the surrounding, even if the ice cube is acquiring heat from the surrounding, the temperature is not going to increase. So where does this energy go? Okay. So the temperature of the system does not change after the melting point is reached till the ice melts. Until the ice melts, its temperature does not change. This happens even though we continue to supply heat. Even if the heat is supplied to the ice, when it starts melting, its temperature is not going to change. So this heat gets used up in changing the state by overcoming the force of attraction between the particle. So when the ice start melting into water, its temperature should increase, but its temperature is not increasing. So where this energy is going, this heat energy is going. So this amount of heat energy is being utilized by the piece of ice to change its state. Okay, as this heat energy is absorbed by ice without showing any rise in temperature, it is considered that it gets hidden into the contents of the beaker, and it is known as latent heat. As we cannot see the sign of increasing of temperature even if heat is supplied, that means the heat is being used by the ice piece internally. So we are not able to see it. That is why it is known as latent heat. The word latent heat, latent it means hidden. The amount of heat energy that is required to change 1 kg of solid into liquid at atmospheric pressure at its melting point is known as latent heat of fusion. This statement is very important. It may come in your examination that define latent heat of fusion. So you should keep this one in mind. So particles in water at 0 degree centigrade, this is 0 degree centigrade, that is 273 Kelvin, have more energy as compared to the particle in ice at the same temperature. This is also very important point. Now see, if you compare ice at 0 degree centigrade and water at 0 degree centigrade, then the amount of energy associated with the 0 degree centigrade water is more than the amount of energy associated with the 0 degree centigrade ice, because 0 degree centigrade ice, when it absorbs latent heat, it becomes 0 degree centigrade water. So energy at 0 degree centigrade ice plus latent heat is equal to energy at 0 degree centigrade water. So suppose this ice, it is having X amount of energy. Okay. Now when the latent heat is supplied, this latent heat is going to be added with this X amount of energy. So X amount of energy plus latent heat will give you Y amount of energy. Now at X amount of energy, it is at solid state. Y amount of energy, it is at liquid state. So Y is more than X. Okay. So here X is ice, Y is water at 0 degree centigrade. Now, when we supply heat energy to water, particles start moving even faster. This one we have already discussed. At a certain temperature, a point is reached when the particles have enough energy to break free from the force of attraction of each other. At this temperature, the liquid starts changing into gas. So same thing happens in case of liquid also. So when solid state it change itself into liquid state, from 0 degree centigrade water till certain temperature till 100 degree, if we keep on increasing the temperature, that means if we keep on supplying the amount of heat, then its temperature will increase. So it is at 0 degree centigrade water, from 0 degree centigrade water to 100 degree centigrade water, the temperature of the water will increase. Okay, at 0 degree to 100 degree. At 100 degree what happens? Same concept of latent heat will come into picture. So this 100 degree centigrade water will absorb the latent heat and it will convert itself into 100 degree centigrade steam. Okay, 0 degree centigrade ice, it absorbs latent heat, becomes 0 degree centigrade water. 100 degree centigrade water absorbs latent heat, becomes 100 degree centigrade steam. Okay, this temperature at which a liquid start boiling at the atmospheric pressure is known as boiling point. Earlier it was known as melting point. Now it is known as boiling point because liquid boils. Boiling is a bulk phenomena. What is bulk phenomena? That means all the liquid that you have taken, they started boiling together, okay, at one time. Particles from the bulk of the liquid gain enough energy to change into the vapor state. Now here these particles from the liquid will take energy and they start changing themselves into vapor state. this is solid state. When heat is supplied to solid state, it will convert itself into liquid state. Now again, when heat is supplied to liquid state, it will convert itself into gaseous state. When the gaseous state is cooled down, it will convert itself into liquid state. When the liquid state is further cooled down, it will come back again to solid state, that is point 1. Okay. So next point is sublimation and deposition. Okay. What is sublimation? What is deposition? So far we have seen that solid state will convert itself into liquid state, liquid will convert itself into gaseous state. But there are certain cases in which solid will directly convert itself into gaseous state. So this is solid state of matter, this is liquid state of matter, this is gaseous state of matter. In general, solid converts itself into liquid, liquid converts itself into gaseous. So in case of sublimation, what happens? Solid will bypass liquid and directly convert itself into gaseous state. So this is known as sublimation. What is deposition? Deposition means when gas is cooled, rather than converting itself into liquid and solid, it will directly convert itself into solid state. This is called deposition. So a change of state directly from solid to gas without changing into liquid state is called sublimation, and the direct change of gas to solid without changing into liquid is called deposition. These two are very, very important. So Kelvin is the SI unit of temperature. So 0 degree centigrade is equal to 273 Kelvin. Okay. So this is all about today's class. This is all about this video. In the next video, we'll continue our discussion. Okay. Thank you and have a nice day.